Alright, so picking up where that last video ended, my phone died, sorry about that. So we basically left off with the quotient rule, doing implicit differentiation with the quotient rule. So again, just to recap, we've got the bottom times the derivative of the top minus the top times the derivative of the bottom set equal to the derivative of 4. At this point, we have really no choice, but we have to just FOIL everything out, combine all of our like terms, move anything that does not have dy dx over here, and then factor out dy dx from the remaining terms. So we're just going to FOIL these out real quick. 3x times 1, 3x times negative 1, derivative of y, so that would be negative 3x dy dx. Distributing our y, we got 1y, and then negative 1y dy dx. So important thing is just not to get not to lose terms or anything like that. Again, the repetition of the dy dx, it's kind of like back when we were first introducing the idea of limits, and we had x's and delta x's and stuff like that. So it's just a lot of terms flying around. So I'm going to FOIL here, but I'm also going to distribute a negative sign, x times 3 with a negative, x times 1 dy dx, again made negative, so that would be negative 1x dy dx. Negative 3y is going to become plus, and then negative 1y dy dx is going to become same thing, positive, so plus 1y dy dx equals our 0. Sorry, you can't see that. Okay. So then now, like I said, it's just moving anything that does not have a dy dx to the right side of the equal sign, and at the same time I'm going to just go ahead and put my equal sign down here. I'm just going to go right down the line. Anything that does not have dy dx is going to move over here, but be made opposite, obviously. So we got negative 3x. When we move that, we've got minus 1y. When we move that, this plus 3x, I didn't see that right away, so that's going to cancel out our negative 1. And then we've got a minus 3y also. When we move that over there, we can see now that everything remaining has a dy dx. Negative 3x with it, negative 1y with the derivative, negative 1x with the derivative, and then positive 1y with the derivative. So we can factor it out, dy dx. We can also go ahead and combine our x's and y's. So we've got negative 3x minus 1x, so that's going to give us negative 4x when we combine them, and then we'll combine our y's as well. Negative 1y is going to cancel this positive 1y, and if at that point everything else is factored and brought down, we can just divide our negative 4x to the other side. So dy dx, the derivative found implicitly is, let's combine our like terms here. Those cancel. We're left with, oh, this cleans up incredibly well, negative 4y over negative 4x. So the derivative is going to be, the negative 4's cancel. It literally differentiates all the way down to just y over x, unless I made a mistake, but I don't think I did. So even if there's some sort of computational mistake, the idea is there, and it's kind of consistently the same. So that wraps up the implicit differentiation. I apologize for the incredibly long delay. I'll get things sorted out so that your videos can get loaded earlier in the morning each day that we have them. And yeah, let me know if you guys have questions. Shoot me an email, shoot me a text, and I'll go ahead and compile any questions together on a video tomorrow morning. All right, thanks you guys. Have a good day.